If you have a trinomial with leading coefficient not 1, then trying to factor it is a little more challenging. So here's an example. Let's say you have 6x squared minus 5x plus 1. How do you factor this? Well, to study how this gets factored, first you have to observe that things that would, two linear polynomials that would multiply to such a thing should look like ax plus b times cx plus d. Now, if you try to expand this so that you can reverse engineer to figure out what should go in here, you should actually do it by doing the multiplication. So ax times cx is acx squared. Ax times d would be adx. B times cx would be bcx, and b times d is what you have here. And then these two like terms would be acx squared plus ad plus bc x plus bd. Okay, so and we're saying that AC is like 6 here, and BD is like 1, and AD plus BC should be negative 5. That's how we're viewing this. And to go the opposite way, the real challenge is somehow looking at this middle one, negative 5, as AD plus BC, and splitting into two terms. And how do you figure out what's AD and what's BC? So really the question is, what is AD here and what's BC there? And the way you approach this is by looking at this and saying, oh, if I multiply the first one and the last one, that's ACBD, which is really AD times BC. See, these two are exactly the same as that, because multiplication order is just changed, and changing order does not change the final outcome of the product, right? So this is ABCD, this is also ABCD. So they are the same thing, but the reason I like to write it this way is because this thing is a product of these two things, whereas the sum of the two is here. So look at it like this. If I want to know AD and BC, I know that the product should be the multiple of the first and last, 6 times 1, which is 6. And then the sum of them, AD plus BC, is equal to negative 5. Okay, so what two numbers have the product as 6 and sum as negative 5? Well, because they add up to a negative number and the product is positive, we know that these two should be both negative numbers, right? And since 6 is 2 times 3 and 2 plus 3 is 5, we do see that negative 2 and negative 3 should be AD and BC. Okay, so once you have figured out what AD is and what BC is, by the way, I'm going to streamline this in a better way in the next example. This is just trying to explain to you why things work that way, and once you're convinced that this approach does reverse engineer the product, then I'll give you a better step-by-step guidance. But the goal here is for you to think with me how to actually deal with this problem. So once you've figured out AD and BC, what you do is you want to split this into two things like that. So you want to rewrite this as 6x squared minus 2x minus 3x plus 1. So negative 5 is negative 2 plus negative 3. It's split like this. And once it's split like this, then you see that the first two terms is you can factor the ax out of it, because it was created by ax times something, right? So the first one you can factor the ax. The second one you can factor the b out. And that will actually do the reverse engineering of the next step. So what you do is you take the first two and factor as much as possible. In this case, they're both even numbers, so 2 is a common factor, and they are both divisible by x, so 2x is a common factor. And what you're left with is 3x times 2x will be 6x squared, right? And then minus 1 times 2x is negative 2x, so write it like this. And then the first one, the second two, the next two items, you can factor the minus 1 and make it as 3x minus 1. Notice how pulling the minus 1 out makes the positive 1 as negative 1. And once you do this, then you see that these two are common factors, so you can factor that out. And if you take this away, then the remaining ones are 2x and negative 1, and that's what you have. And if you're not convinced, you can actually expand this by FOIL to see indeed this is equal to this. So yeah, let's quickly evaluate. So check. Let's check. 2x minus 1, 3x minus 1 multiplied. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is positive 1. So actually it's exactly the same as that, right? And then you combine the like terms and you have 6x squared minus 5x plus 1. Done. So this is indeed the factor of the previous one. Okay, so that's what's called factor by grouping. And let me do another example so that you can be more confident of this approach. So how do we factor this one, for example, by factor by grouping? Okay, so step 1 is multiply first and last. And when I say first and last, I'm assuming that your trinomials are, or your trinomial is already written in the decreasing order of the powers. Okay, so if you have x here and then x squared there, then you should switch them so that it's ordered well. Okay, so in this format, you multiply the first and the last, which is 6 times 2, which is 12. And step 2, find two numbers that multiply to number in step 1 and add to the middle number. So in other words, you want two numbers a and b whose product is 12 and whose sum is the middle number. In our case is 7, right? Now notice that a times b is a positive number, so it's either both are positive or both are negative. But since their sum is positive, we're looking for two positive numbers. Okay, and how do we find the two numbers? Well, think about all the possible ways 12 can be broken down. 12 is 12 times 1. It's also 6 times 2. It's also 4 times 3. And check that 1, 2, 3, 4, 6, 12 are all the possible divisors of 12. So that's the only way. And among them, the ones that add to 7 is this one. 4 plus 3 is 7, right? So we know that a should be 4 and b should be 3. Okay. And then step 3, what you do is break up the middle using numbers from step 2. So by that I mean 6x squared. This is now written as 6x squared plus 4x and then 3x plus 2. And as you can see that 7 is 4 plus 3, right? So indeed these two are still the same. So these two are still equal. And then step 4 would be factor by grouping. And this method is called factor by grouping. Okay, you group the first two, group the second two, and factor. So 6x squared and 4x, they're both even and they both have x in there, so I can factor the 2x, and that leaves you with 3x and then 2. Now the next two, they don't share any common factors, nor you have a minus. If you have a minus in front of the x, then you should factor that out as well, but they're both positive, so in this case just group them. There's no more way to factor it. And then once you factor it this way, factor by grouping, then you see that you have the same 3x plus 2, right? So when you see that 3x plus 2 appearing, just think of them as just one single object, so which means that you can factor that as well. So you can factor the 3x plus 2 out, and if you do that, what's left? From 2x times 3x plus 2, 2x is just left, whereas you should view this as 1 times 3x plus 2. So if you factor the 3x plus 2 out, you have 1 left, and that's the final answer. Okay, so that's how you factor trinomials. Now, there's some other ways that you can factor, and sometimes if you have other cases, sometimes you have something like 3x squared plus 9x plus 6. In this case, you can factor 3 overall, because you notice that 3, 9, 6 are all products of, it's all divisible by 3, right? So they're all multiples of 3, so you can factor that out. So in this case, there's an overall factor. And once you do that, then this is just a simple trinomial factoring, because the leading coefficient is 1. So you just have to figure out two numbers that multiply to 2, whereas they add up to 3. And that's just 2 and 1. 2 plus 1 is 3. 2 times 1 is 2, right? So you have 3x plus 2, x plus 1, and that's done. Okay, so sometimes you can factor by an overall number, but this is like rarely. Okay, very rarely this happens. Okay, this does happen, but don't count on it. Usually it's not true. And what's another case? Well, another possibility is when you have, say, you still have an overall factor. You factor the 2 out because everything is even. So you have 6x squared plus 5x plus 1, right? And when the numbers are not too big, what you can do is you can just think about doing this by trial and error. So you can use trial and error case. Trial and error. Okay, so trial and error method does the following. Since 1 is just plus 1 plus 1, right? If this is plus, then you know that these should be both positive, so put plus 1. There's no other way. This has to be 1 and 1. And then you have this 6. So to create 6x, either it's 6x and x, or 3x and 2x. So you try both. If it's this, then you get 1x and 6x. So you're going to get 7x if you add them together, right? 1x plus 6x is 7x, but you have 5x here, so that doesn't work. But in this case, 3x plus 1 and 2x plus 1, 2x and 3x, they add up to 5x. So indeed, it does match. So this is no good, but this is good. So the final answer is 2 times 3x plus 1, 2x plus 1. So this would be just doing trial and error. And if the numbers are not too big, this is good enough. Often this is faster than trying to factor by grouping. Okay, so let me try to do another example here. I say 8x squared plus 8x minus 30. How do you factor this? I see that these numbers are all divisible by 2, so I'm going to factor the 2 out, which gives you 4x squared plus 4x minus 15. And since you have negative 15, one should be negative and the other is positive. So let's try to do this by trial and error and see what happens, okay? So you have one as negative 5 and the other as positive 3. Okay. And then since 4x squared is either 4x times x or 2x times 2x, and by the way, since you have 3 and negative 5, since these two are different, it does make a difference if you put an x here and then 4x. So there are actually just three possibilities, either this times this, or this times this, or this times this. So all you have to do now is to figure out which one does give you the correct answer. Let's try this. Oh, by the way, I just realized that you should also think about the case when you have negative 3 and plus 5. Okay, so actually that gives us 6 possible cases. But you know what? Don't think about this for a while. If there's a case where you have negative 8 instead of positive 8, then you can use the same numbers with negative 3 and positive 5 chosen. Okay, so this should be a second consideration after this. Okay, so let's see. If you have 4x plus 3, x minus 5, the first and the last would create 4x squared and negative 15, no problem. It's the outer and the inner that we are worried about. The outer is 4x times negative 5, which is negative 20x, whereas 3x gives you positive 3x, that's negative 17x if you add them. So that's no good. We want 4. Sorry, it's not 8, we want 4. So since it's not 4, this is no good. This is no good. Let's move on to 2x. 2x plus 3 and 2x minus 5. In this case, the inner and the outer gives you negative 10x. The inner gives you positive 6x. Adding them, you get negative 4x. Actually, this is good because now since negative 4x and positive 4x are just the sign difference, that means we chose the wrong sign, and it should really be negative 3 and positive 5. So it will be 2 times 2x minus 3 and 2x plus 5, and that should do the work. Now, so that's what I mean by doing trial and error, and it's really a matter of preference. I think there are many people who are used to just doing this trial and error, and they will be happy with doing it like this. Or some of you might not like this method and you just want to do the method by factor by grouping. So let's try the factor by grouping method and see what we get. Okay, so up till here it's the same thing, but we multiply 4 and negative 15. We multiply them. 4 times 15 is 60. So we're looking for two numbers whose product is negative 60 and whose summation is 4. Now, because negative 60 is a negative number, we know that one number is negative and the other number is positive, right? So we're looking for 60. I want to break this up into two products and make their difference equals to 4. That's the problem, okay? I want to make two numbers, so 60 times 1. The difference is 59, right? And then it's also 30 times 20, and the difference is 10. And then it's also 15 times 4, in which case the difference is 11. Sorry, this should be 30 times 2. In that case, the difference should be 28. Right? Okay, and then let's go further. What if you had, 15 is 3 times 4, right? So I can rewrite it as 5 times 3 times 4, which is 12. In this case, the difference is 7. And then, what's another one? 5. So 1, 2, 2 times 2, 3. 3 times 20. Difference is again 17. 4, 5, 6 times 10. Oh, yeah, the difference is 4. So this is the one. Okay, once you've figured out that the two numbers whose sum is difference is 4 and product is negative 60, you should see that negative 10 times 6 is negative 60 and negative 4 plus 6 is negative 4. Okay, so once you figure this out, then the next step is to rewrite this as 2 times 4x squared. 4 is now, sorry, should be negative 10. 4 is now negative 10x plus 6x and then minus 15, right? And this would be now factored by grouping, so this would be 2x minus 5. This has a common factor of 3, so it's 3, 2x minus 5, and then finally if you factor the 2x minus 5 out, you get 2 times 2x plus 3 times 2x minus 5. So you get the same answer this way, okay? So choose your method. Either do it by trial and error or do it by using this method where you multiply the first and the last. So that's in general what should be done.